Good evening, all of you. Welcome you guys. Very good evening to all of you. Welcome you all. So I hope we are live. So here. So will you please comment about the things? So is my audio video is clear to all of you? Tell me. Please comment about this thing here. Is my audio video is clear? Are you facing any difficulty in this audio video? Let me know. Fine, all of you. Chalo. So here, welcome you guys. All of you, welcome you all. So, and let's have the great announcement about the Unacademy All India Test Series. Unacademy is going to conduct the All India Test Series, and with the test series, you will get to know the what are your weak areas where you need to concentrate, and so that you can able to improve yourself by practicing the number of questions and what are the important topics you will get to know. For that purpose, this All India Test Series is very helpful. You will get to know your All India rank, right? And to enroll for this All India Test Series, you can use a code B V Reddy. And if you have enrolled for this course, that is, you can able to access all the 6 mock tests you can able to access. And the beauty is all these mock tests are completely free. So you no need to pay any single rupee also. So try to utilize these opportunities. And you can plan this Unacademy subscription with a no cost EMI without paying any additional charges. You can able to avail it. And Unacademy, so all these digital notes are available in the app as well as a website. You can able to access those things. And there are new batches we are starting for the GATE 2024, and from November 24th onwards started, and you can find the top educators of India you can find in the single frame. And to enroll these batches, you can use a code of B V Reddy. By using a code of B V Reddy, you can join in Unacademy plus platform as well as iconic, whichever you like. And by using this B V Reddy code, you will get a great discount, and you will get the personalized guidance from me, right? Next, these are the batches we are starting. You can see now here. And Unacademy complete the test series program. You can plan this Unacademy test series. Unacademy test series are, you can see, and these are the features of Unacademy Plus as well as iconic. For the plus students will get the top educators will take the classes and digital notes test series. In addition to this, iconic students will have a additional benefits of customized doubt solving feature, printed notes, one-to-one mentorship, strategy and study program, and interactive open house sessions. Fine, all of you. So last we have discussed some of the important things. We have completed the coordinate systems and the vector calculus हमने discuss किया. All these topics we have covered now here. And right, so here if you have any doubt in the previous classes, please let me know. So we'll cover those topics and then we'll move to the next topic. Tell me now, कोई doubt हुआ तो पूछो जल्दी फटाफट. अगर कोई doubt हुआ तो बोलो जल्दी फटाफट. हमने so these 6 points हमने discuss किया. If the divergence of vector is 0, then that vector is called as a solenoidal and divergence free vector. हमने conservative के बारे में भी हमने discuss किया. And we have concluded that any solenoidal vector can be expressed as the curl of some other vector, and any irrotational vector can be expressed as the gradient of some other scalar function. Chalo? And all of you do like the session and share to all your friends. First of all, I am expecting so here everybody do like the sessions, and that is a thing we expect from you fellows, and we are providing the best content we are providing for you, all of you. So here, and we are expecting the small favor from you. So all of you do like the sessions and share to all your friends, right? and you can follow me in the Telegram channel. So here, there you can search my BV Reddy. You can search the BV Reddy. There you can get this complete. The running notes is there now. That running notes will be available in the Telegram channel, BV Reddy. So you can search. You will get my profile. You will get now. You do message me in there, and you can get the complete class notes, the running notes, and then the PDFs and DPP and short notes you can get. And you can search, this is my channel, that is BV Reddy GATE. You can search now here. I hope आप सभी को मेरा प्रोफाइल मिल गया. Everybody do search this thing here. Everybody got this my profile. You can message me. So I will share the complete class notes and all. Now, so first of all, you tell me now any doubts in the previous classes, all of you. Shall we continue? हम आगे बढ़ेगा, बोलिए. चलो. Now, let us see some of the problems. Let us have a look on the problems. Look at now here. The value of closed line integral of dl along a circle of radius 4 meters. Look at now here. So this is the circle. The circle having the radius is given. Let us consider this is a radius circle. So, and this is a circle. Can I call this circle is a cylinder? Can I consider circle is a cylinder? Can you consider? All of you tell me. So here in case of a cylinder, what are the parameters we have? Tell me. Cylinder we have rho comma phi comma z. Rho comma phi comma z. Z is the height of the cylinder. You tell me now here, as height of the cylinder tending to 0, what happened to cylinder? As the height of a height of a cylinder is 0, what happened to the cylinder now here? The cylinder will becomes what now here? Circle बनेगा कि नहीं बोलिए? It will become circle. हाँ ना बोलिए everybody. Yes. Now, so I can consider this is my cylinder. I can say this is my cylinder. Circle is nothing but cylinder having the height is 0. Now, so this I am calling this as a rho. Now tell me radius of the cylinder. I want to find the integration of this vector. So for that purpose, what I am taking is, I am taking a small strip here. Small strip we have taken. The small strip. So we need to find the integration of closed line integration of dl. Now you tell me now on this line, if I move along the circle, can you tell me now what are the variable parameters? Can you tell me now what are the variable parameters here? We have a rho, phi, z. What is the z value? Tell me z value here is a 0. Tell me now on the cylinder, rho value to constant, it is not changes. But phi value variable or not. What is the change in length along phi direction? Tell me, which is a rho d phi. Change in length along the phi direction is what you tell me, rho d phi. So I can say dl, only the variable is rho d phi, which we can write it as, this is integration of rho d phi. Can you tell me this is phi limits? Phi limits we can say 0 to 2 pi, complete circle na. So if I do integration, what I will get, you tell me now, which is equal to 2 pi rho. And how much is rho value? Tell me. Rho value given 4. So that means what I can say, the answer which is equal to 8 pi 4 into. So which will get this as 8 pi. All of you बोलिए this thing. अगर आपने ध्यान से देखा तो here, so this is the circle, the radius is given as something is given. Can you tell me the radius? So this is closed complete length of the circle. Now tell me this is nothing but perimeter, circumference or not? What is circumference now here? Which we used to call this as 2 pi r, where r is a radius now. So what's the option now? Tell me D. Isn't it? Now you tell me now here. Now take the next problem. The region So as I told you now, so we have totally for EMF, we have totally nearly 400 problems we have for the electrical के लिए. 400 problems. In this 400 problems, I have selected some important problems. I have selected those important problems I will discuss in the class. I will discuss some important problems. So remaining problems you practice. अगर कोई doubt हुआ तो you will discuss in the class. Right. So you can see the numberings now here. Randomly we have selected some problems. One, and this is third problem. Right. Now take this next problem. Now, so the region specified in the cylindrical system has a volume. Volume in the what system? What system here? Cylindrical system. Cylindrical system. What are the elements we have? Rho, comma, phi, comma, z. Volume. Volume means what we required. How many parameters required? You tell me. That is differential volume dV, which is given as. So we need a change in length along what direction? Rho direction, phi direction, z direction. Yeah, you tell me now what we required here, which is equal to rho, d phi, and dz. Tell me all of you. Rho, d phi, dz. So we need the volume. This is a differential volume. To get the volume, what I need to do here? I need to do the volume integration. We have to do here. Rho, d phi, and dz. So tell me now here. We can split the limits now here. They give the rho limits are what now here? 3 to 5. Rho limits given as a 3 to 5. We can say rho terms, we can say rho into d rho. And phi limits are what you tell me now here? Phi limits they given now specified here. How much these phi limits are? That is pi by 8 to pi by 4 into d phi terms. And the z limits are what you tell me? That is 3 to 4.5 into dz. So let's integrate, get this value. Tell me how much you'll get this value. Volume, tell me all of you. Rho limits, which is given as rho square by 2, limits 3 to 5. And phi limits d phi, which is given as what we can say here? Pi by 4 minus pi by 8. And then dz, so which is 1.5. Simply if I get this value, how much is answer? Tell me. Which is given as 1 by 2 into which is the 25 minus 9. This is pi by 8 and which is 3 by 2 now. How much is answer? Tell me. How much this answer? Everybody tell me this thing. Final calculation you need to do carefully. Okay. What is the final answer? All of you do like the session. Everybody, first of all, I am finding very few likes now. All of you do like the session. First of all, everybody. Final answer is pi. Isn't it, Vikesh? His answer is 5. Final answer is pi. Check this thing. Everybody got the same thing? 3 pi by 2. Yeah, so calculation is, so carefully do this calculation carefully. Okay, so which is equal to 1 by 2 into which is equal to 16 into pi by 8 into 3 by 2. So tell me now what we'll get now here. A 16 है, 16 को मारा, so which is equal to 3 pi by 2 is answer. बोलिए. कैलकुलेशन आप करना पड़ेगा केयरफुली. Right. चलो, all of you do like the session, everybody. All of you do like the session, everybody. चलो. Next. Now you take the next problem. Consider a closed surface S surrounding a volume V. where r bar is a position vector. R bar is a position vector of the point S. Now they are asking to find the value of this integral. See this thing, what they are asking to find? They are asking to find the closed surface integral of, what you tell me now here, 5 into r bar dot n cap into ds, where what is this n cap is a, where what is the n cap is a unit vector normal to the surface, and generally so ds is the surface area. Surface area is vector quantity, and the direction of surface area generally, which we used to write it as the ds, it is the magnitude of the surface area. To give the direction of the surface area, which we use as, what you tell me now, n cap, where n cap is a unit vector normal to the surface, which will give the direction of the surface area. So now instead of using this word ds into n cap, I am simply using as a ds bar. कोई प्रॉब्लम हुआ बोलिए आपको? Instead of using the ds into n cap, I am using as a ds bar only. So I can write, modify this equation as surface integral of 5 into, I can say, r bar dot, I am combining these two, I am writing this thing as a ds bar. Is it fine, all of you? Now which is given as, now here this 5 is a constant, take outside, 5 is a constant, take outside, and then close surface integration of, what you tell me now here, that is r bar dot ds bar. Now here r bar is a vector quantity, right? Can we apply the closed surface integral? Can I convert into a volume integration? By using divergence theorem. By using divergence theorem. So this equation, which we can make it as, what we can say here, by using divergence theorem, it is converted to the volume integration. Now here tell me, that is del dot of r bar into dv. बोलिए, there is no mistake. So they used to use that notation. So generally they used to follow the notation like that, dv, where r bar is what now, position vector is given now, which is given as, position vector means what, xi plus yj plus zk. Tell me all of you, this is the position vector, xi cap, yj cap, zk cap. Now can you tell me now del dot r, divergence, which you will get it as 1 plus 1 plus 1, which will get this as a 3. So this value we are replacing here. अगर हमने replace किया, so this is 5 into, what I can say now here, this is volume integral of 3 into dv na. So which we can say this is 15 into volume integration of dv. So integral of dv, which we can call this as a v, I can say na, integral of dv, which we can call this as a v. So the answer which is given as, what we can say here, 15v. So what's the option, tell me now, D. Right. Fine, all of you. Like this we need to solve these problems by using, now you see this thing here, these problems we have solved very easily with the help of the divergence theorem and the Stokes theorems. These theorems will help you a lot to get the answer easily. Chalo. So let's continue the next topic now here. Now take the next problem here. So this is a GATE 2000, I think so, 20 problem, I think so. For electrical 2 marks question, this one. I think GATE 19 or 20, I am not sure. This is nearly 20, I think so. GATE 20 for 2 marks question. You see this thing here. For electrical. See this thing, kaun sa option here, tell me. They given this vector. You can see now first figure. This is a x, this is a y, and this is a z. Now you tell me now for this, if you see carefully, if I find the x, what is the nature of this field, you tell me? What is the nature of field? Is a diverging, rotational or curling nature? Here this field is what nature, you tell me now here, which is a diverging nature. हाँ ना बोलिए. So in this case, for x case, divergence is non-zero. So here divergence is non-zero. कौन सा option you tell me now here? In this case, divergence non-zero. So B and C में होगा. Next here y case, what we can see now here? Curling nature. Curl is non-zero, tell me. Curl is non-zero here. Here curl is non-zero. Here in this case, you see the field is now here. It has a diverging nature as well as rotational nature also. In this case, how the field is now diverging as well as rotational. So कौन सा option tell me now इधर? Option C. That what we have discussed. बहुत अच्छे से हमने किया ना this thing. Done. चलो. Fine. So इस प्रॉब्लम में कोई डाउट हुआ क्या, बोलिए आपको. चलो नेक्स्ट वन. Let's move to the next topic, everybody. The next one here, static electric field. What is meant by static electric field means what? Static electric field means in this case, the charges are at rest. Charges are at rest. When the charges are at rest, then what we have, tell me now here. Electric field we have, magnetic field we have, both we have, tell me. When the charges are at rest, then we have, in this scenario, only electric fields will exist. Only electric fields will exist. Only electric field we have. And this electric field, how these electric fields are? This electric fields depends upon what, tell me now here. This electric fields depends upon space. Depends upon space and independent of time. And independent of time. ऑल ऑफ यू बोलिए, इसमें कोई डाउट हुआ तो मेरे साथ डिस्कस करो. इंडिपेंडेंट ऑफ टाइम. So since these fields are depends upon space and independent of time, that's why these fields are called as a static fields. That's why these fields we are naming it as what, you tell me now? Static electric fields. These fields we are naming as what? Static electric fields. These are called as a static electric fields. And the study of the static electric fields, which we used to call this as what, you tell me? Electrostatics. Study of the static electric fields is called as what? Electrostatics. ये सारा पॉइंट्स क्लियर है आपको, बोलिए. ये हमेशा आपको दिमाग में होना पड़ेगा. So here you need to have this, all this information आपको दिमाग में होना चाहिए. Done? Right. Now, so what is the reason for this static electric field? Electric field, you tell me. Space means what we have here? Space means we have only one space. What we have, space means what? Depends upon space. What are space parameters are? What are space parameters are? X, Y, Z. If we move here, if we have taken this point, now here this location we have something like we used to say here in your Google map. If you say here something here, this has some locations now. If you change this thing, we have some other. Change this thing, some other here. So from point to point will changes now. That is called as a space. We have space means we have only one thing we have. We don't have so many spaces. Remember, only one space is there. There is no different type of spaces are not available. Okay, space means it is a point changes to here. If I change the point now, electric field will changes. That is the meaning of that. Now, what is the reason of this electric field? You tell me. Which will causes the electric field? You tell me. What will causes the electric field? So charge. The charge we have the dq is there now. dq, which is called as a basic charge element. Basic dq, which is called as what? Basic charge element. Because of this dq only we have the electric field will cause us. All of you tell me. dq is called as a basic charge element, and the dq will cause us what? It will cause us electric field will cause us. So this dq, which we used to call this as a source for electric field. The dq is what? You tell me now here. The dq, which is the source for electric field. What is the source for electric fields? You tell me. dq. The basic charge element, that is a dq. The dq is the source for electric field. So because of the dq we have a electric field we have, right? ठीक, चलो बोलिए. Next, Coulomb's law. Coulomb's law. Let us consider we have a two charges we have in the space. Let us call this charge, we are calling it as a q1, and this is the another charge we have, this is the q2. We have two charges, we have q1 and q2s. Now, and there is a line joining the two charges like this. This is a line joining the two charges. And let us call the position vector. Let us call the position vector of q1. Let us call the position vector of q1. I am calling it as a r1 bar. Position vector of q2, I am calling it as a r2 bar. And what is meant by position vector? That is a location of the charge with respect to the origin. Now, and I am defining one term that is called as f1. f1. I am defining a term f1, where f1 I am calling it as a force. The force acting on q1 due to q2. f1 I am defining as a force acting on q1 due to q2. Right. Electric field get charged from q. q never be dead at any one stage. What yeah? Electric field is because of the charges. Remember, electric field get charged from. Arya, Radha Krishna, I think so. You are asking the question something different. You tell me now what you want to ask. Reframe the question. What you want to ask. So, because of the charges, we have electric field. Remember one thing. Because of the charges, we have electric field. Now you ask what you want to ask again. Because of the charges, we have electric field. Not electric field not causes the charges. Remember. Because of the charge, we have electric field. Source for charges, source for electric field is a charge. F1 is a force on Q1 due to Q2. Now you tell me now this and this F1, which I am calling this as a F1 bar. I am calling F1 bar. Charge never be die. So charge never die. Charge is what you tell me now here. That is what we can say. Charge can never die. Okay, don't worry. Charge will never die. F1 is a force acting on Q1 and due to Q2. Now this force which will be given as, let us a distance between these things, which we are calling this thing as a R1. If I call it this one, I am calling this as what we can say here, capital R1. I am taking the notation. This notation I am taking this as capital R1. Now, so this force acting on Q1, which is given as, that is 1 by 4 pi epsilon into Q1 Q2 by, this is R1 square into AR1 cap, where AR1 cap is a unit vector along the direction of this R1. Here we are finding the force on where, you tell me, on Q1 due to Q2. Wherever you want to find the force, that point is a funnel point. Wherever you want to find the force, that point is a funnel point. Here where you want to find the force, you tell me. So I want to find the force on Q1, so that Q1 must be a funnel point, and the distance means final point minus initial point. Distance means final point minus initial point, which is given as final point distance. Q1 is final point, the distance is R1, so that I can say R1 bar minus R2 bar, which is given as what we can say, R1 bar minus R2 bar. And this ER1 cap, ER1 cap is what, unit vector along the direction of R1, and which is given as what I can say, R1 bar by modulus of R1 bar. R1 bar by modulus of R1 bar. Fine. Now I am defining the one more term here, F2 I am defining, where this F2 I am calling it as a force acting on Q2 due to Q1. Force acting on Q2 due to Q1. Right. So where this F2, so the direction of F2 is like this, where, which is a funnel point here, tell me. Here which is a funnel point, R1 minus R2 may reference. So here, that's what I told you, remember. Look at now here, what is this F1 is? F1 is what now here? Force acting on where? On Q1. Force acting on where? Q1. So wherever you want to find the force, that point is a funnel point. Wherever you want to find the force, that point is a funnel point. You want to find the force on Q1 na? So Q1 is a funnel point. So, and Q1 distance is a funnel distance. Q1 distance is a final distance. So here this Q1 distance on Q1 I want to find, right? So on Q1, this word is very important. And so due to Q2, wherever you want to find anything, that point is a funnel point. Distance means hamesha final minus initial. Final minus initial. We're finding the, so here if I say here I am here, so if we say this point is A and this point is B. Now if we are moving like this now from A to B, now tell me now, if I ask the distance between the 2 points A and B, what I can say now here? Final minus initial, final point, B point minus A point. Final point minus initial point we need to write. Now tell me now, F2 is a force on Q2 due to Q1, and which is given as what I can say here, F2, tell me. That is 1 by 4 pi epsilon into Q1 Q2, and this distance which I am calling this thing as something, let us say R2 bar I am calling, so which is given as R2 square into A R2 cap. Here you tell me now what is R2 here. Here you tell me now what is R2 here. R2 bar. Here Where you are finding the force, you tell me now. On Q2 you are finding. So that means Q2 must be a funnel point. On Q2, so that means Q2 is a funnel point. So how should write the R2? Tell me. Final distance minus initial distance means what I can say, R2 bar minus R1 bar. Next, what I can say now, this AR2 cap unit vector will use the direction of the force F2, that is R2 bar by modulus of R2. Done everybody? Chalo, next one. Now here this is the basic kahani of sabhi ko kya hoga. Here we are going to see some important points we are going to highlight here. All of you ध्यान से देखो इधर. Let us see one by one points. Important points we are going to see carefully. Look at now here. All of you ध्यान से देखो इधर. Now if you see carefully this term, what is this term will give you, tell me this term. Tell me this term. This term will give us a magnitude of F1. And this ER cap is there now. This will give us a direction of F1. And here also this term will give us a magnitude of F2. And this term will give us a direction of F2, right? Direction of F2. अगर आपने ध्यान से देखा तो can I say that the magnitude of F1 and magnitude of F2 both are equal? Mod F1, which I can say, which is exactly equal to mod F2, tell me. Magnitude of F1 equal to magnitude of F2, isn't it? And if we talk about with respect to direction, what happens, tell me? F1 bar, which is given as a minus of F2 bar. F1 bar, which is given as directions are opposite direction, now tell me. So here these directions are, this is F1 direction, F2 direction, so completely opposite. There is a phase difference between F1 and F2 is how much, you tell me? 180-degree phase shift. Right, so from this is like what we can say now, action reaction. This is the form of action reaction. So from this what we can say here, Coulomb's law obeys the Newton's law. Coulomb's law obeys the Newton's third law, action reaction. Right? Everybody? Next. Now you tell me now here, the force between the two charges, if we consider magnitude if we consider, which is given as, in general, what I can say, force now I can write in general simply, that is 1 by 4 pi epsilon into, I can write this thing as Q1 Q2 by R square into ER cap. बोलिए, simply I can write like this now here, the force. So अभी ने हमने डिस्कस किया. So this term will give us a magnitude of the force, and this term will give us a direction of the force. If I want the magnitude, we can use only this term I use. If I want the direction, I will go for this term. If I want the direction, then I will go for this term. Right? Next. But I don't want to denote like this. We can denote, but I don't want to denote like this. इसीलिए मैंने mention किया. मेरा notations are this thing. F1 means force on Q1 due to Q2. I don't want to use a F12. So here and now here, can I go for this notation? Some other notation I can use. So let us say here, if instead of this F1, can I go for this A is a force on Q1 due to Q2. Can I write the A formula like this? Here these are F1, F12, F21. All these are simply just for notations only. Okay. I don't want to confuse you on this topic. So that's why directly I use only the F1, F2. Okay. These are some simply dummy parameters only here. इसलिए मैंने मेंशन किया व्हाट इज F1. My F1 I have mentioned. Right. Next, this is the magnitude and directions. Right, all of you. Now I am defining a term called as a electric field intensity. I am defining a term called as electric field intensity. Here, so the electric field intensity E, which is given as, that is the force acting on a charge, will be given as electric field intensity with a units of what we can say here, newtons per coulombs. The units are newtons per coulombs, and we have another unit we have for electric field, that is volts per meter, and we use mostly volts per meter we use as a unit, right? This is the electric field intensity. Now from this, here this is the force. Now here can I get my electric field intensity here? Can you tell me the E is the electric field intensity, which is given as what I can say here, 1 by 4 pi epsilon into what I can say now here, Q by R square into AR cap. Q by R square into AR cap. Now you tell me now here what is this term will gives? This term will gives what you tell me now here, magnitude of electric field. Magnitude of electric field intensity. All of you बोलिए. This term will give us a magnitude of electric field intensity. And this AR, this term will give us a direction of the electric field intensity. This term will give us direction of electric field intensity. Everybody बोलिए this thing. कोई शक वाली बात है क्या इसमें? Right. Now you tell me now here, carefully see this thing here. So this AR will give us a direction of what? This AR will give us direction of whose direction will gives, you tell me? Whose direction it will give us? AR is a direction of the force. Where this AR will give us what, you tell me? Where this AR will give us a direction of the electric field. अगर आपने ध्यान से देखा तो here you see this thing here. अगर आपने ध्यान से देखा तो here, where this AR same or not? Is this AR and this AR both are same or not? Same ही तो है ना? That means what I can say now from this, what we can conclude, you tell me. The direction of electric field is same as the direction of the force. The direction of electric field is what I can say, the direction of force. Hana, बोलिए, tell me. Right. So here, what we can say now here, the direction of electric field. Remember, most important thing here, the direction of electric field is same as the direction of force. The direction of electric field is same as the direction of the force. Is this point clear to all of you? Tell me. Done? Chalo. Now, as we know that the force between the two charges, magnitude of the force, which is given as in general 1 by 4 pi epsilon 1 by 4 pi epsilon q1 q2 by r square. Tell me. 1 by 4 pi epsilon q1 q2 by r square. Now can you tell me now what is this epsilon here? The epsilon is a permittivity of the medium where the charges are placed. Okay. Now let us consider here. I have two charges. We have the two charges q1 and q2. So assume that the two charges which are kept in a air. The medium in the two charges is a air. Can you tell me the force between the two charges? That force I am calling as F naught. Can you tell me the force between the two charges? I can say here 1 by 4 pi epsilon is epsilon naught, I can say now. Epsilon naught into q1 q2 by r square. Tell me everybody. Now the same two charges we have, the same two charges q1 and q2. So here now the medium between the two charges is filled with some dielectric, some other than the free space air they placed now here. Now you tell me the force between the two charges क्या होगा? Now the force between the two charges I am calling as F, and which is given as what I can say here 1 by 4 pi. Now this epsilon is given as epsilon r into epsilon naught. What I can say q1 q2 by r square I can say now. Tell me everybody. Where this F naught is, what you tell me now? F naught is a force between the two charges when the medium is a free space air, where F is a some other medium. Now if I take the ratio between these two here, then what I will get, you tell me. First of all you tell me now which force is greater, you tell me. F or F naught? Which force is greater? Which force is greater, you tell me now, F or F naught? Which is greater, you tell me now, first of all, F or F naught? इस दोनों में कौन ज़्यादा है बोलो? Is F naught is greater or F is greater? Tell me. So from this what we can say here, this F which is less than or equal to F naught I can say now. Tell me. F which is less than or equal to F naught. बोलिए everybody. F is less than or equal to F naught. F naught is greater. Now you tell me now here. Right. Aryan, so here, so Sunday या Monday कुछ भी नहीं होगा हमारा. सो हियर क्लास के लिए संडे या मंडे कोई भी नहीं होगा. सो हियर कोई भी हमने नहीं रुकेगा. Right, remember. And now you tell me now here we have got this is. Now if I take the ratio between F by F naught, can you tell me what I'll get? If I take the ratio between F by F naught, can you tell me what I'll get the ratio between these two? F by F naught, what I will get, you tell me. बोलो यार अभी नहीं हमने देखा ना इसका. You see this thing here. So this F naught which is given as 1 by 4 pi epsilon naught into Q1 Q2 by R square, right? And what about this F, you tell me here? 1 by 4 pi epsilon naught into epsilon R Q1 Q2 by R square. So from this what I can say now here, F is equal to, I can write this as F naught by epsilon R, tell me. F is equal to F naught by epsilon R. So with epsilon R we have epsilon R, which is what you tell me now here, always greater than 1 now. Epsilon R which is always greater than 1. So that means, so because of this reason, so what you tell me now, F is less than or equal to F naught. Done. So now you tell me now here, so here now, so what happens now here, I have two charges. By if I insert, so here if I place, I have two charges, we have initially we have two charges Q1 and Q2 we have. So initially these two charges, between the two charges medium is a air. Now I have taken the same two charges, we have taken same distance now Q1 Q2 we have. Now the medium between the two charges is filled with a glass. Medium between these two is filled with some glass. Then what happened to the force between the two charges when the medium between them is a glass? And the medium between the two, it is a glass, what happened to force now here? Increases or decreases? Increases or decreases? Yeah, this is a problem here which is given in the recently GATE 2019 में आया a problem. When the medium between the two charges is inserted between some glass, what happened to force between them? Because of this, what happens now? Force between them decreases. All of you tell me. The force between them decreases. Done? So first of all of you do like the session, everybody. Yes, obviously, the medium can change the nature of force value, not nature of a force. It will change the magnitude of the force will changes. It will affect the magnitude of the force. Right? It does not change the nature of a force. If it is attraction, repulsion, repulsion only. But if we cannot change the nature, it can change the magnitude can changes. All of you tell me. Next. Now you see the things now here carefully. The same thing I want to interpret the same concept differently. Now here, where F is the force between the two charges with a medium between them is some dielectric, that is 1 by 4 pi epsilon r into epsilon naught, and tell me now here Q1 Q2 by r square. Boliye. So this formula which I am modifying this thing as 1 by 4 pi epsilon naught into Q1 Q2 by, that is square root of epsilon r into r ka whole square. Can I write like this? Now this force which I am writing it as 1 by 4 pi epsilon naught into, so Q1 Q2 by, I am calling this as a r square, where this capital R which is given as square root of epsilon r into r. Did you understand this thing जो मैंने किया? Where this small r is there now, where this small r which is called as an actual distance between the two charges, where small r which I am calling this as actual distance, and where this capital R I am calling this thing as an effective distance, which I am calling this as effective distance. Now you tell me now here, So now you tell me now क्या होगा, you tell me. So now you tell me now here. So because of the dielectric, when the dielectric is introduced between the two charges, what happened to effective distance between the two charges? What happened to the effective distance between the two charges? Increases or decreases? When a dielectric is inserted between the two charges, what happened to effective distance between the two charges? Effective distance. This is the way this is my effective distance now. I have taken this capital R is effective distance. Where this effective distance is this term now here, square root of epsilon r into small r. Small r is the actual distance. And how much the epsilon r value always greater than 1 now? Since epsilon r is greater than 1, so that means effective distance which will be increases or not? Effective distance increases. By inserting a dielectric medium between the two charges, effective distance increases. By how much? By how much? Square root of epsilon r. So what we can say now here? By inserting a dielectric between the two charges, between the two charges, the effective distance between them, the effective distance between them increases. Yes, exactly. Since the effective distance increases, that's why force increases. All of you tell me. The same thing we are considering, different analysis we are doing, quite different analysis. Everybody tell me. Right. Now you tell me now here, I want to extend this concept little more. I want to extend this concept little more. 6 points completed, 7th one here. ध्यान से देखो इधर. Now, I have two charges here. Here this is one charge Q1. This is another charge Q2. So assume that the total distance between the two charges is R. Total distance between the two charges is R. Fine. Now, if the medium between them is air, can you tell me what the force between the two charges? Air means we can say epsilon is equal to what you tell me? Epsilon naught. We can get the force. Right? If the medium between them is some dielectric ferrite, if the medium between them is some dielectric ferrite, so having epsilon is given as epsilon r into epsilon naught. In place of epsilon, we can use this thing, we can get to know the force. Right? बढ़िया. But लेकिन मैंने क्या किया, you know here, what I did now here, मैंने differently मैंने सोचा. Just imagine now here, other distance, half of the distance I had filled with one type of medium. कुछ distance मैंने कुछ type of medium के place किया. Let us consider this distance, which is t distance, and having filled with a relative permittivity is epsilon r. And this part is then a remaining part is there now. This distance which we have air only. Okay. Now I want the force between the two charges. समझ आया वो प्रॉब्लम बोले पहले? To understand the problem, first of all, everybody tell me. मैंने कुछ distance, let us say t distance I have filled with one type of medium, and remaining distance, that means r minus t distance, I have not filled with anything. Okay, now देखो इधर what we are going to write now here. Now can I write the effective distance now here? R, effective distance. Look at now, totally this distance is how much, you tell me now, t, and this is filled with some dielectric of epsilon r. So then because of this, what happens now here? Tell me now here. Actual distance is t, but it is filled with some dielectric. Because of the filling the dielectric, the effective distance will becomes what we can say now, this is epsilon r into t होगा, plus, and here how much the epsilon r for the free space a, which is 1 na, so which we can write this as r minus t. ये चमका कि नहीं बोलो? So is it clear, you tell me? जो मैंने बोला ये चमका कि नहीं? बढ़िया, बोलिए. Right. Now this is. Now can you tell me the force now here? Which is given as 1 by 4 pi epsilon or epsilon naught here? Epsilon naught into what I can say here? Q1, Q2 by what I can say, tell me now here? Square root of epsilon r into t plus r minus t whole square. बोलिए this thing. बोलिए this thing. Now आपने ध्यान से देखो इधर. So मैंने क्या किया? So what I did now here, I have filled with some medium. मैंने बोला, let us consider this is here, this is also air only. That means पूरा medium air only. Let us consider. If the complete medium is air, then how much the epsilon r in this location? Tell me. Epsilon r is 1. If the epsilon r, if I replace this as 1, what happens now here? ये t ने t को मारेगा, t ने t को मारेगा, finally will get this r square will come now. That is a basic formula. Tell me. ये t ने t को मारने के बाद हमको डायरेक्टली बेसिक फार्मूला हमको मिलेगा कि नहीं, बोलो? That is the basic formula. बोलो, ये बात क्लियर हुआ कि नहीं सभी को? बहुत बढ़िया. Done? Right. The next one here. These things. And Coulomb's law has a limitations. Coulomb's law has a limitations. What the Coulomb's law is limitation is what now here? Write down here. Coulomb's law is valid only when the charges are at rest. Coulomb's law is valid only when the charges are stationary. If the charges are moving, Coulomb's law is not applicable. And the next one here. And Coulomb's law is valid, another limitation, is valid only when the Physical dimensions of the charges. Physical dimensions of the charges. Charges are very small. Are very small compared to the distance between the two charges. Distance between the two charges. Physical dimensions are very small compared to the distance between the two charges. What is the meaning of this thing? Physical dimensions are very small. What is the meaning of this is now here? That is, the charges must be, what type of charges are? Point charges. That means the charges must be, what we can say here? Charges must be a point charges. तभी Coulomb's law applicable होगा. If not, Coulomb's law is not valid. Chamka, Coulomb's law is valid static electric field, yeah. So static electric field का मतलब क्या है? Charges must be only ना. So why it is not valid for static field? It is valid for static field ना. Madhu, what you are saying, I didn't understand here. Extra 2AB times will added. No, yeah. No, it won't be. Check karo. It won't come like this. Check it now here. Here, see the formula what we have written. R minus T. I have not taken a square for R minus T. For this whole thing, this is the square. You see the formula what I have written. So I didn't do the square of this R minus T. There is no square for it. Where we have square, you see? Where we have square, for this is the square, yeah, I did. You see this thing. Okay. Is it fine, Madhu? Tell me. Done. Right. So all of you do follow me in the Telegram and yes, electro. So if it is a time varying case, it is not valid. Time varying case, it is not valid. Yes. And you do follow me in the Telegram channels and WhatsApp. You can follow me here, and so here in the Telegram channel you can search my name and you will get it. Now first of all of you do like the session. I didn't find the likes. I just find only 2 likes I'm finding here. All of you do like the session. Everybody, first of all, do like the session and share to all your friends and juniors. So let them join. Okay. Yeah, that's for the today's session, and we'll meet the tomorrow same timing 9 o'clock. Okay, fine. Okay, might be, so it is not updated. Yes, we'll discuss what are the problems we are discussing. Those problems are here only. So that's why only, so here we cannot continue the more classes here. What we can do here, and we can have a more interaction. So in the special classes, Unacademy special classes, इसीलिए you do follow this as a, you can follow me in the Unacademy. So BV Reddy, you can search my profile BV Reddy. You will get so many special classes you will get. And right now I am doing the special classes. Tomorrow morning I am doing the 9 a.m. we are doing the digital. I am doing digital revision course. There we are going to discuss about the only practice session I am doing, only problems, the PYQs I am doing in the Unacademy. You can go and search my profile BV Reddy. There you can get the so many special classes you can get tomorrow. And today onwards I have started the revision course on digital logic circuits. Today is the first class we had, and tomorrow also we have a classes daily 9 a.m. we have a class. Okay, you can do follow the Unacademy classes also, and you can search me there, you can find my profile, you can find, and if you have any doubt you can contact me. Okay, right. Yes, that's for the today's session, and we'll meet tomorrow. Tomorrow morning we have a, remember, tomorrow morning 9 a.m. we have a digital revision class is there. Tomorrow morning we have a digital revision classes we are doing. There we'll discuss the PYQs, DPP, only problem session we are discussing. Okay, yeah, that's for the today's session. We'll meet the next class. See you, bye bye, take care.